This isn't AI. From start to finish, you're watching us build the studio rack, 3.3 meters of it. We've hidden electrical wiring inside the aluminum frame for lighting, and 3D printed a full exhaust network for all my 3D printers in here. This workbench is a dream come true, a dedicated home for all my desktop machines, and may easily be your dream too. So stay with me, because I'm about to show you the whole build, literally step by step. I'm recycling the unused aluminum extrusions left over from past projects, cutting them all down to length on my dedicated saw. It has a press that holds the workpiece down as it cuts, so it is as safe as it can be. This workbench is built entirely from 4040 and 4080 black aluminum profiles, and within one session, every piece is cut down and carefully sorted out for further processing. Just like any other projects we take on, there's extensive drilling to be done. But right now, a new machine has just landed at my door, so let's unbox it first. QIDI sent over their newest creation, the QIDI Plus 5, and oops, there's something else in there. This printer has a massive build volume, large enough to print a life-size dog. And for all the parts we need for this project, we'll use this brand new printer. There's so much to like about this printer. Cutout handles on the sides make it easy to move, the large touchscreen is practical and easy on the eye, and a magnificent LED bar sits right below the build plate, something none of my other printers have. But what about the nasty print fumes? The QIDI Plus 5 included a 3-layer air filtration system, capturing 99.5% of dust and particles. But if you know me well, you already know, I always go the extra mile. Well, the very first thing I did was model this funnel, to divert the exhaust to an air filter. And this is the very first print on the QIDI Plus 5, which has been extremely impressive. QIDI has fitted this printer with a next-gen motion system, which uses 1.5 GT custom belts, upgraded X-axis linear rails, and a lightweight tool head that eliminates VFA, which explains the extremely smooth surface you can see on this print. And without tweaking the hole tolerances yet, the fit for the magnets is already absolutely perfect. And yes, I know what you are thinking. So many magnets for one job, just to hold it in place. But this is exactly the magnetic strength this funnel needs. And to be sure nothing falls off, I tapped M3 threads into the back holes, adding 4 screws to lock it in position. This should do the job, keeping it from falling off and channeling the exhaust air into the filter. It's a temporary setup, just so I can print ABS for this whole project. So let's try out the huge build plate. I played around with the software a bit and got started printing the prototypes for this project. This will surely take a while to print, so let's get back to building our aluminum extrusion structure. Before we assemble anything, the holes in the extrusions have to be done right first. This is our 4040 freehand jig for drilling 4mm holes into the frame. Those let us fasten the wood panel with M4 wood screws later during the assembly. Using this method, we'll achieve internal fastening with no visible screw heads. And for the electrical wiring we're running inside the frame, these jigs make the 8mm holes. Because the spacing between the holes and their diameter is critical, we've tested across many projects, and by now, we've perfected it. And with these precision jigs that need no measuring at all, even the holes are perfect. We've always built with blind joints, joinery that locks down from within. It's what lets us create the strongest joints and the strongest structures, but it takes heavy upfront planning and a whole day dedicated to nothing but drilling. Creating these precise holes, drilled at their designated locations with their intended diameter, all serves a practical purpose, and you'll soon see it during the assembly stage. If you like what we do, you will be able to find everything at thealuminumcarpenter.com. Without a multi-material changer, I can't print this dual-color part. We made a request to QIDI, and they immediately sent it to us, and we're so grateful for that. So it's only fair that we show our audience more of the QIDI Box. One of the striking features that sets this apart from others is its active heating, which can keep our filament dry at up to 65 degrees Celsius while we print. But on the printer itself, 2 features stand out most. The active chamber heating up to 65 degrees, which clearly prevents warping, and the polar cooler, which stops heat creep. and not forgetting the print head that's capable of 370 degrees, letting us print a larger range of filament types. The setup is a no-brainer for me, and it took roughly 10 minutes to get everything running. These 4 PTFE tubes feed filament into the printer. Behind it, only 2 other cables and the power cable are needed. I'd always imagined multi-material printing to be really complicated, but honestly, QIDI have made multi-material printing really simple. And with that, all the 3D printed parts of this project will come only from this magnificent machine. So, is it expensive? Not really. Check it out for yourself using the link in the description. With all the parts 3D printed, let me take you through a few minutes of preparation. The QIDI Plus 5 has given me amazing prints, and we'll need to press in the heat inserts now. My method for heat inserts uses an aluminum block, and plenty of you asked what it's actually for. 2 reasons. It keeps the insert flush to the surface, and because aluminum conducts heat so well, it draws that heat away much faster. I've sped these clips up in the edit, of course, so in reality it's a lot slower, but I'm sure you get the idea. What I'm building here is an exhaust bridge, a network of hoses that carries air from below the workbench to above it, then pulls it out of the workshop through the window. I've built several successful exhaust systems before, and for this one, I want to improve on everything I learned from those earlier designs. Next, let's move to the parts that mount the power supply unit onto the aluminum frame. These specific parts need to be specially customized, because the PSU doesn't have mounting holes made for that. And furthermore, my objective of fully concealing the wires makes this design even more of a necessity, not just for aesthetic reasons. Safety-wise, I've decided covers are needed too, to cap off both ends of the PSU, so no one will ever come into contact with live electricity. I've even printed them in bright colors, so everyone knows there's something there to watch out for. Therefore, at this point, I've run out of ways to improve it. Thanks to the QIDI Box, these parts come out in dual colors, with my logo printed right onto them. Every screw here is internal, holding the exhaust bridge from the inside. Unlike my previous designs, this one's built to be screwed on, which is why the threads are modeled into the parts. Now it's about making sure they fit just right. The dimensional accuracy of the QIDI Plus 5 has really impressed me, because a fit this perfect is exactly what I needed. Reliable machines like this are what I love. They get projects done faster, with hardly any setbacks, which means I can also pre-assemble the fasteners, screw on the temporary cap, and head back to the workshop earlier to continue our assembly. And if you've been waiting for me to start building, thanks for being patient. Now for the longest extrusions. There's still plenty to do before we get to assembly. First, we mark our reference lines, so we know exactly where the adjacent extrusions need to sit. Using our 40 series marker jig, we line up on the lines already drawn and add 2 new ones, exactly 40 millimeters apart. This tells us precisely where to mount the other extrusions. And because this monster of a workbench is so big, there are several vertical braces we need to place markings for. The extrusions we prepared are already labeled, so it's essential we grab the right one for assembly. And for this step, we're using washers. I go with washers in a lot of sections here because I want more surface area at the contact point, while keeping the diameter small enough that it won't stick out past the sides. And with that, let's put on our very first piece, using our best methods to create the perfect joint that we will repeat throughout the whole build. We're not locking in the joinery just yet. The Allen key goes through the holes we drilled earlier, and it's just briefly tightened for now, because we need to flip the setup over to use flush plates for alignment. But this is very wobbly, so I add 2 temporary extrusions underneath to steady it. And now, we can move on and complete the joinery. The trick here is to slightly loosen it. Align it precisely between the 2 marked lines, briefly tighten it, apply the flush plate well across both extrusions, and then finally lock it down for good. We'll keep the flush plates on till the end, while we mount the rest of the aluminum extrusions. This way, the flush plates give us extra holding strength, so later, when we add brackets at those corners, the joints won't get pulled out of position. With Douglas on the other side, we had it ready in no time. It's a 2-man job, so it goes easier here, 1 man guiding the bolts and washers into each slot. Is this project very difficult? Not really. You just need to know how to do it, and you need a partner. The section we're building now is the top of the workbench. The braces that span between the two longest extrusions are needed to support the desktop machines we'll be bringing over. Because this little room in my workshop is turning into my mini print farm, it'll keep up with the growing orders for our precision jigs and give me space for the R&D on many future versions. I've wanted a dedicated space like this for a long time, and it's finally coming together. Over here, we're reinforcing every single joint with external brackets. These were dismantled from another project, so they didn't cost me anything. Okay, the joints are already done with internal joinery, so why add the external brackets? 2 reasons. Strength, that's pure overkill, and the added weight this workbench really needs, so it can carry every machine I throw at it. To close off the extrusion slots, we always use slot covers. They're a staple in everything we build, non-negotiable in our workflow. And since I designed this structure myself, I know exactly which slots won't be used, so we can seal them up right now. This part is tedious, sealing every slot we won't use. That's why we break it into sections, bit by bit. Push too much into one session and it wears you down mentally. But there's a big payoff. It keeps dust and dirt out, makes the whole thing easy to wipe clean, and hides every drilled hole. And the look? A sleek, strong, all-black workbench. At this stage, we can take all the flush plates off. They've done their job, keeping every extrusion flush and stopping the joints from shifting. We'll set them aside for now, but they'll be back very soon for more precision work. To install the vertical extrusions, we flip the whole structure over. Those braces we built earlier are a mix of 40-40 and 40-80 profiles, and every vertical goes onto a 40-80 because that gives us the best perpendicular strength. This is what we call the twin blind joint, 2 hidden internal fasteners sharing the same space. And it's only possible if you thought it through back in the design phase. Our alignment jig is required here, locking down 2 extrusions on the same plane with a flush plate on the outside to lock the alignment on the exterior. Tighten the bottom one first, flush plate comes off, and tighten the other. And that's how you build a perfect twin blind joint, flush on every side and strong enough to carry my print farm for years to come. And as I mentioned earlier, we tackle the slot covers portion by portion. Otherwise, the vast number of slots to close would be mentally overwhelming. With that, we finished one large section of the structure, and we have to move it away to free up our assembly table for the next section. The next section is much the same, with only minor variations. We'll build 3 short legs for the bottom front of the workbench, and those legs caused a few problems down the line, which I'll get into. But first, we need to bring everything up to the same stage, which means the brackets, slot covers, and flush plates all need to be handled first. And once this frame is properly secured to the assembly table, we can work on reinforcing these 3 legs. Just so you know, the plan is to add LED lighting to this slot. But I also want to reinforce the legs with some external brackets I recycled from another project. And now, the 2 are on a collision course. Of course, I did model this in 3D extensively, and I spent loads of time planning this part. It worked in the model. But real life always throws more at you than theory ever does. So I jumped straight back into Shaper 3D and reworked every one of these parts away. When you download the Studio Rack design, you will be getting my finalized version. Now, to strengthen those same 3 legs, I decided to just add recycled brackets behind them instead. I showed Douglas how to do it properly and how to trim slot covers flush and neat right at the edge of an extrusion. That's the second frame pretty much finished. Now it's time to build the sides of the structure. The frame needs to be laid out in the correct orientation first. It's easy to get orientations wrong when it comes to drilled holes. And now, let me introduce a new standard end fastener for 40-80 extrusions. It's shorter on one side, which frees up more room in the extrusion slots for other purposes, without compromising joinery strength. To complete this corner perfectly, we'll need flush plates again. The drilled holes provide access to the internal bolts, and 3 flush plates placed in these positions will guarantee perfect alignment while we fully lock down everything inside. And after that, the flush plates come off, leaving you a perfect corner, completely flush on all sides. So now, let's bring all the sections together into one solid aluminum extrusion frame. We use regular standard end fasteners for these joints, and everyone has to be prepared on top of the verticals before the next section comes over. Without Douglas, there's no way I could do this on my own, as you can see. Every standard end fastener goes into the slots first, and only then can we slowly wriggle the frame into position. It's a simple job, but a tricky one. Every bolt has to sit at exactly the right height, otherwise the frame won't pass. And once we've brought it into the final position, it's just a matter of tightening and flushing. Our perpendicular alignment jigs are used to hold everything in place before we apply the flush plates, and a ladder is needed now, because it's way too tall to reach. Seeing the structure come together like this, I'm glad I built it mostly from recycled materials. It saved me loads of cash, and it's brought me closer to my dream workshop furniture. People reach out to me all the time, at least 20 requests a week from all over the world, each one describing someone's dream project. I love reading every single one. So what about you? Got a dream project you want to build? Tell me in the comments. Now, with the sides up and secured, attention turns to the brackets and slot covers. Those have to be done thoroughly before we take the next step. Therefore, the structure has to be flipped over to get these done on all faces. And at this point in the project, the aluminum frame is completely done. And that's when we can move on to the wood preparation. These laminated wood panels were ordered brand new. They have to be in the exact dimensions that fit our structure, and also processed according to what I had planned for them. We took precise measurements all over the panels before cutting into them, because we only get one shot at it. These holes are essential. It's not just cables passing through, but entire exhaust hoses, feeding a whole exhaust ecosystem. Grommets like these are fine if it's only cables. The exhaust system, though, that's where I have a completely different idea. But we'll get to that later in the video, because that's a whole chapter on its own. The corners of the wood need notching out wherever they meet the aluminum frame. Between wood and metal, the wood gives way. Using our Japanese handsaw and a jigsaw, we quickly remove material first, before the hand router takes over to clean up the job. And the middle sections of the wood need notching out too. That part's a little more work than usual. But of course, we could have done this a little cleaner, but that would mean buying a better jigsaw. I'm keeping costs low on this project, so for the cleanup pass, I'll leave it to the flush trim bit instead. For the cleanest notch-outs, I redesigned and improved my flush trim jigs. They're built to this project's exact dimensions, with the numbers printed right onto the jig. With this particular design, the wood panels sit on top of the aluminum extrusion frame. It gives the best surface strength by far, but the downside is each panel has to be customized like this to make way for every vertical leg. And that's why we've developed every specialized tool needed to handle each complexity this project throws at us. The other side needs to be notched the same way too, achieving the exact same perfect results. But for the other side of the panel, we'll need to produce a slightly different notch out, about half the length, because two panels have to make way for just one vertical leg. And just like that, the same perfect result. And now we'll have to tackle the notches at the middle section. We'll use a different jig for the flush trim here, first scoring the wood on the exit path, then making a flush trim along the jig, creating a perfect notch out for the vertical profiles to sit in later. The wood panels are now prepared, and this is exactly the way I planned this project to be. It's time to lay the electricals into the aluminum frame. For the first time in so many projects, I've decided to use these grommets to line the drilled holes we made earlier. Some holes come out perfect, others a little frayed. Wherever wiring runs through, a grommet goes in for extra protection. Although after so many projects I've done, there's really no need for it. But because some of our audience shared their opinions, I've decided to show a process they'd like to see. Therefore, grommets it is, wherever we need to thread a wire through. I've planned a web of cables, neatly running through multiple drilled holes, completely hidden within the aluminum extrusion, to create an electrical network that lights up the structure with LED. And over here, You're watching how I ran the mains cables, then covered it all with slot covers, completely out of sight. This takes loads of careful planning and 3D modeling up front before we even cut the first extrusion. Download the design files, and you can follow every step to the same outcome. We're ready to wire the first LED strip, but first the structure has to go onto its back, and those brackets from our earlier mistake have to come off. As promised, more grommets get inserted into the drilled holes before the LED wires go in. And to get the LED strip on, it's just using the adhesive tape on the back, rolled deep into the aluminum extrusion slot, all across the entire length of the workbench. We'll pull this strip off later, but not before a test run, because I want to show you this first. Translucent slot covers will go on, acting as the light diffuser, as well as protecting the LED from moisture. After that, it's just a few basic connections, then we can switch on the power and test the lights. I also made a new change. Those extrusions are cut clean and sharp, so I designed a cap for each leg. The last thing I want is someone brushing against one and cutting themselves. These caps go on before the leveling feet, entirely to protect our skin. And Douglas is inserting the feet to achieve a specific height for the workbench, temporarily, because I know the floor isn't level. Installed like this, these rubber feet are incredibly strong. Just 5 of them hold this entire workbench up. Next up, the power supply unit. It converts the power to 12 volts for my LED strips. To hold it, I need to build these custom mounts, made specifically for this structure. The electronics have their own dedicated spot at the back of the structure, safely away from accidental touch and clearly visible in red. The mains gets connected into the terminals with an additional wire to the earth connector. This is a necessary safety feature, which will help ground the entire aluminum extrusion frame in case of an electrical fault. Grounding needs bare metal, so we scrape off the paintwork to expose the raw aluminum, then lock the fork connector down right onto it. A multimeter lets us check conductivity right across the frame, and once that's confirmed, we tighten everything down. All right, the mains wiring is now complete, and we can cap the section off permanently. Now it's time to make the connections coming from the LED strips. I've already made wire extensions to reach the power supply unit, and we've got to fish all of them through the grommets and multiple internal drilled holes for fully concealed wiring. This is a very delicate task, using only flexible silicone wires, making sure we don't damage them when running through the holes. And I'm wiring both sets, for the top and bottom LED strips at the same time now, then sealing the wires in with slot covers. On this particular day, I'm working alone in the workshop. That gives me room to move at my own pace, indulge my extreme OCD, get everything right before moving on, and clean every mark off the extrusions. In fact, when I work alone, the footage I can film is better. I don't need to worry about another guy in or out of the shot, and I can get better camera angles for my audience. But this project is demanding. I need Douglas's help. This structure isn't just heavy, it's made up of nearly 900 components. But today, putting on the tabletop, I can still manage myself. I've added quite a number of flush plates all over to hold the wood for me, flush to the back of the structure. Clamps will hold it there for me, while I get the positions right for both panels. And what we need to do here is permanently fasten the wood panels onto the aluminum frame from the underside. Here's one more example of how useful flush plates can be in any workshop. And when you're working solo, that usefulness is magnified. The gap is finally closed. With every tool holding the wood panels in position, we can bring out our specific wood screws. This is where we use the 4mm drilled holes in the extrusions. Going through the 4080 profiles, we'll use an 80mm screw, and for the 4040 profiles, we'll use a 40mm screw. And to make it rigid, we need plenty of screws. Time to take the flush plates off so we can flip the structure. The screws aren't finished. We've only handled the upper side so far. And now it is really heavy. The wood screws are all in, so now we tidy up the rest of the top section. Sealing the slots with covers, peeling off the sticker labels, and fitting the brackets for wall mounting. Of course, that's not all. We still need to briefly tidy up the wires with slot covers, because they're supposed to pass through one of the holes in the tabletop. And for the dedicated exhaust system I want to build, we need to test fit it right now. These 3D printed parts form a hollow bridge from the bottom of the workbench to the top, letting me connect a network of hoses that pull air from my 3D printer chambers straight out the window. I was worried about tolerance issues, so I planned for a tiny bit of play within the holes. And I want this setup fastened to the aluminum frame rather than the wood panels for maximum rigidity. And this time I designed a screw-in part rather than using magnets, so there's no way for it to fall off unnoticed, leaking print fumes into the workshop. The test fit was a success, and we'll have to tackle another line of LED in a very different way now. Because as much as I'd like it to be, this extrusion slot isn't a clear straight line. Internal fasteners block the way, so the solution is to route a path around every internal bolt. Therefore, the LED strip is cut into 4 equal lengths, and it takes some extra effort to connect them back into one continuous line of light. These are my go-to for solderless connections, but reliable as they are, I still test every connection before pasting the strip into the extrusion slots. And at the same time, I've decided to use another type of clip connector to connect all the wires to ease future maintenance work. The wires crimp into it, and both ends just snap together to form a connection. It's my first time using these, so they need plenty of testing. And once that works, all that's left is organizing everything inside the extrusion slots, then hiding it all behind slot covers. To carry the connection to the next line of LED, I've pre-made a few short connectors that feed through the drilled holes in the extrusion legs to reach the other side. Using this method, I didn't find a use for the soldering iron throughout this entire project, making things easy on my aging eyes and speeding up the electrical connections for me. But of course, in this video, I made it look easy. To be really honest, this part alone took me 3 hours to complete, and I hope this has been enough to earn a like and a subscribe from you by now. Okay, the entire line of lights is done. What's left is to make the remaining connections at the power supply unit and check for any possible errors. Both lines of lights have to be right first. Then, we seal up any exposed wires with slot covers and cap the other end of the PSU with our 3D printed cover. With this, we've completed the electrical section of our project, and we still have a bit to go before the assembly is totally done. The rest of the 3D printed exhaust bridges have to go on now, before we flip the structure again. And this time, it's to attach the remaining 2 wood panels. Because the wood prep was done well, the panels dropped into a perfectly precise fit. And before flipping the structure again, we clamp the panels to the frame, then drive in all the wood screws, just like before. This is the last time we'll ever see the bottom of the workbench, so every slot cover needs to go on right now. And remember that bottom line of LED, time to peel it off. Why? Because there are still more wood screws to drive in, and the LED strip has to sit on top of them. Once the screws are done, the strip and slot covers go back in place, and we'll flip the structure upright for the very last time. While we add the finishing touches, I really want to say I'm glad you followed along this whole video. This is one of my dream projects, and honestly, that anyone wants to watch me build it means a lot. So good job to you too. Alright, let's now bring the workbench into the room. It is extremely heavy. Just watching, you'd never tell. We can only manage a few steps at a time, veins popping out of our necks, faces like we've been struck by lightning. And if we're going through this much pain, you're witnessing it with us. I designed it to just barely fit through the door, tuck snug into the corner, and sit flat against the walls. The floor, as expected, is nowhere near level. That means carefully working through all the leveling feet until everything sits true. But to do that, we'll need our pallet jack to lift this brutally heavy structure. And from there, it took us like 30 minutes of endless feet adjustments to get the leveling right. Then, the power is connected, and this is how it looks with the lights on. To me, this is an absolute beauty. What do you think? Okay, let's permanently fasten it to the wall. The walls are concrete, so we'll need the usual hammer drill and wall plugs. Once the wall mounting is complete, the workbench is held up not only by the 7 legs, but also by the screws planted into the wall. As for the dedicated exhaust system, that's coming in part 2. For now, this 3D printed part caps it off, and then it's onto our logo. Because one look, and this workbench is clearly made by the aluminum Carpenter. And that's the point. I want everyone who sees it to recognize the brand straight away. Part 2 of this project will be coming shortly, with many surprises along the way. Make sure you're subscribed so you don't miss it. And if you want to build projects like this too, visit our website, thealuminumcarpenter.com.